we've described our classes. Now what we want to do is start developing and describing the attributes for each of our classes. And this is going to help us set our model up for use in a database. The attributes are the data elements that describe the characteristics of an instance in a class. So what does that mean? Well, if you think of our previous REA examples, a class may be customer. Well, the instance would be a particular customer. Let's say we are a pen and pencil manufacturer, so one of our customers might be Office Depot. Another customer might be Walmart. So an instance would be one customer, one specific customer. An instance for a sales event would be one particular sales transaction, usually by sales number, sales order number. All right, so the attributes are the data elements that are going to help us describe a particular instance in the class. Attributes include things like the type of data, maybe a default value. So we may, as a small business, if we're a small business, our default value for customer and the state they're in might be Mississippi. We may have constraints. Things like minimum, maximum values. Other things that are going to help us, maybe it's going to be constraints that a date format looks like, month / day / year. So that would be a constraint. Another thing we need to consider with attributes, our attributes include the primary key. So what do we mean when we say a primary key? A primary key uniquely identifies an instance in a class. So the key there is uniquely. We also have foreign keys. So that gives us, it basically supports links to other associated classes. So you can think about a sale. A sale would be identified uniquely by the sales order number. That's going to be its primary key. That sale will be made to a customer. So that customer ID then becomes a foreign key that supports our ability to link that sale to our customer class. And attributes are going to also include other descriptive elements. Other information we want to know about that particular class, that particular instance within a class. And attributes are listed in tables that accompany Class Diagrams. Now there are a number of ways class diagrams can be set up, so the tables could be off to the side of the class diagram or on another page, or they can actually be included in the class boxes themselves. All right, so let's get back to this whole notion of a primary key. So this could be an attribute, and it could also be a combination of attributes that uniquely identifies an instance of a class. And in database lingo, that means a row in a table. One thing about a primary key that's important, it cannot be null. So what does that mean? Well, that means you can't leave a primary key blank or with nothing in it. And the organization should control the assignment of the primary key. So we as a company should be able to assign the primary key to whatever classes are in our business process. We don't want to be restricted by things that might change on the other end. A customer may change their name. Customer may change their mailing address. Customer may move to a different state. So we want to have control over how we identify that customer. So we use something like a customer number. Think of some examples. Would a social security number be a good primary key? Well, not everybody has a social security number. We might have some customers that are here from another country, are not old enough to have one yet, but they may be identified as a customer. Also, especially with social security number and other personal information, there are privacy issues and laws associated with how that can be used. Social security number used to be a pretty common identifier used by actually companies and assigned to employee numbers, assigned to even student numbers in universities at one point in time. But that's no longer the case with privacy laws. So social security numbers are a good identifier, a good distinguisher, but should not be used. What about names? Well, names are not going to be a very good unique identifier. I wonder how many Joe Smiths there are in the United States. So we don't have something that's going to be unique. We probably have a lot of duplicate names even right here at Ole Miss. Probably not a good identifier. What about a phone number? Probably not. A phone number might be associated with more than one person, and they could change. Think about all of us that only have, say, a mobile phone, and we may just switch to a different carrier and forget the number. We don't care if the number gets carried over or not. We may actually want to change it. How about sequential numbers? Should you use sequential numbers? For a primary key? Well, in many cases that is a good usage. Think about things like your check numbers in your check booklets. Those are identified sequentially. Invoice numbers, sales order numbers are oftentimes created sequentially. And what that does is, that's a good one. So phone number, names, social security number, probably not. Sequential numbers are good. Now they aren't the only type of primary key that you need to use, but they are a good one. You can also help to identify gaps and duplicates using sequential numbers. All right, so primary key we talked about. One of the things we discussed just a few minutes ago is foreign key. So let's get into what we mean with a foreign key. So again, here we have an attribute. Or combination that facilitates linking. Linking what? Well, classes or tables. And when we have associations, basically foreign keys implement the link indicated by associations. So that's the link between classes that are indicated by the associations or relationships that we have in our class diagram. So let's say we've got our person and auto model again. So a person can own 0 to many autos. An auto is owned by one and only one person. Part of the attributes, one of the attributes that we need to know about automobile is who owns it. So the primary key of that person, whether it be a driver's license number or it be a unique identifier that we have in our database for various people, that person's ID needs to be an attribute in the automobile class. So let's take a look at how we might set up some different tables. And you can see tables laid out a number of different ways. So here's one way that we see in the text. So we have customers. And then we will identify the attributes. Customer number, and we'll also identify that as the primary key with a PK. Customer name, customer city, customer state, customer zip, or postal code, customer phone. Now this is simplified. Generally you're going to have a lot more detailed fields in here, but you get the idea. And what those marks are between the cust and the number or the name, that's basically an underscore. Most databases nowadays support names for tables, fields, etc. with spaces in them, but it's good practice to make a table name or a field name all contiguous, because some of the older databases, some old programming languages, some tools may not support that. So we've got customers. We've got an orders table, So the order number would be our primary key. We also have an order date. Delivery date. Order amount. Shipping cost. Customer number. And that's a foreign key. Now, one thing to keep in mind is we could have called this order customer number. So the names of the fields don't necessarily have to be the exact same. From a database standpoint, it's nice if you can keep them fairly similar so you know what they're referring to, but it's not a requirement. As long as you can link them together and they're the same data type, that will work just fine. Foreign key to primary key in another table. So now we have order items. Basically, an order can contain multiple items. I might order 5 CDs from Amazon. So the order item is going to need a couple of pieces of information. I need the order number plus my product number to be my primary key. Then I'm going to have a quantity ordered and maybe a price. And then finally I'm going to have my inventory. And my inventory, as you might guess, has product number as the primary key. And then I've got a bunch of information about the product, product description, quantity on hand, unit issued. So in other words, am I selling these individually, by the 6-pack, by the case, by the pallet, whatever. Current price. And I might even store a standard cost in here for costing purposes, or I may have that may not be something I keep in my table here, but just calculate on an as-needed basis. So I've got basically 4 tables here with all the attributes associated with them that I can now start building databases with. Now finally, we've got a little bit more to cover. So we might have other types of relationships, other UML relationships. So basically we've got special notation to allow us to create relationships that we classify as generalizations. Aggregations, and compositions. Now these are special notation used in certain types of diagrams. You can also model them using all of the tools we've already discussed. Let's take a look at, say, generalizations. For example, if I have autos as a major class or a generalization class, then I can have specific types of autos below it, sedans, convertibles, SUVs. So all of those are going to have different types of attributes associated with them that are unique to those particular types of classes, whereas the automobile class up at the top will maintain all the classes or all the attributes associated with all automobiles, whether it's a sedan or a convertible or whatever. So an aggregation is another possibility. And an aggregation would be basically just a group of individual things that are identified as one. So you could think of the players on a team. And so we identify that aggregation with an open-ended diamond at the end of our line. So that's one type of UML notation that can be put in a relationship there. Players on a team. And then composition would be certain items are composed of sub-items, for example. And the example we see is a book and its chapters. And we denote a composition with a filled-in diamond. So the difference between an aggregation and a composition is the components in an aggregation can stand alone. A player is actually an entity that can stand on its own and be separate from the team. I can be a player with no team. I may not be very useful at that point in time, but I'm a player still. And a book chapter generally does not exist outside the book itself. You would not often go out and just say, I would like to read chapter 28 of Harry Potter. Chapters make the book as a whole and don't necessarily exist separately from the book. There are other types of notations that can be used. You can put a note in something that looks like this with a folded piece of paper over. And these are useful to just allow you to document the system and put some additional explanation in the model itself. From a relationship standpoint, you might have recursive relationships or role designation between various types of entities. So for instance, we might have a supervisor and an employee. And in this case, we've got an employee that works for a supervisor and a supervisor that manages an employee. And this is a recursive relationship because one employee could both be a supervisor of their particular team, but also be an employee that reports to a higher level manager who would be a higher level supervisor. You can even model some of the constraints that would be required in a model. So a person is going to drive an auto, but only with a valid license. So there are a lot of variations on UML and UML notation. We've covered most of the basics, but it can be extended and does have a lot of capabilities that those of you who get into that specialty area might dig into a lot deeper. So one of the things to consider as we have defined our classes, our relationships, our multiplicities, define the attributes in the classes, then we start building the database and organizing a database can be a huge consideration. How do we organize the data? And the number one thing that's done there is something called normalization. So what do we mean when we say normalizing data? Well, basically we're trying to reduce data redundancy. And by reducing that data redundancy, we can help prevent a number of anomalies. First one's called an insert anomaly. One's called an update anomaly. And then we also have a deletion anomaly. So what do we mean? Well, depending on how your tables are organized, you should not be able to insert a sale unless you have the associated customer set up and an associated inventory item to sell to that customer. So in general, you would keep those in different classes, different tables, and you don't want to be able to insert. You want to have the rules in place so that you can't create a sale for a non-existent customer or a non-existent inventory item. Update would mean when you update, say, a customer's name or mailing address, you don't want to have to go all over the database to make that update. You should have it organized so that the customer information related to their mailing address is only listed in one place, and you don't have to go and look up every sale, every cash receipt, and make those changes. And then the deletion anomaly would be, I don't want to have my database set up so that if I delete some item, that I delete another important item in my database that I can't retrieve. For those of you who would keep sales records in a spreadsheet, if I have one sale to one customer and I say, oh, they canceled that sale, so I delete that sale, well, I've captured that customer information, but now it's gone. So if that customer ever calls me back up and says, you know what, I do want to buy something, let's get going, I look silly because I have to get all that information again. What? I just gave you that information a couple weeks ago. Don't you still have it? So, insert anomaly, update anomaly, deletion anomaly. Normalization is extremely useful in transaction systems. Any decent sized AIS or ERP is going to be pretty well normalized as far as the way the data is laid out to help keep those redundancies out of the system. Now, in data warehouses, and OLAP applications, they're designed not so much for capturing and accumulating and organizing transactions, but for reporting purposes. They actually denormalize. The data structure for those purposes. But that's a discussion for another day, and hopefully this helps us get started with how to set up database tables.